So this question tells us that a student is provided with a 5.60 gram sample of ethanoic acid contaminated with sodium ethanoate. The student then dissolves the sample into deionized water and makes up the volume to 200 centimeters cubed. So basically they take this sample and they dissolve it in 200 centimeters cubed of water. The student then takes 25 centimeter cubed samples of this solution and titrates it with 0.35 mole per decimeter cubed sodium hydroxide solution. And the volume of sodium hydroxide solution is actually in this table, and that's what we're going to work through now. So let's look at this table. The initial volume of sodium hydroxide is over here, and the final volume of sodium hydroxide within the burette is over here. And what we're trying to find out is we're trying to find the titer. And the titer is the volume of sodium hydroxide used. So I've just drawn it out over here for you to visualize. Let's say our initial volume is up here and our final volume is up here. We're trying to find out this volume, the volume used, the volume of sodium hydroxide required to titrate it, and that is our titer. And the way we do that is we subtract the initial volume by the final volume and we get the titer. So if you look at table 1 in particular, we'll draw a burette out for that. Its initial volume is going to be like 20.85 and its final volume is 41.10. We find the difference between these two, and that is the titer, which is this. And now it's telling us to calculate the mean titer value, and the way we do that is that we make a sum of the titers and we divide them by however many we have. To calculate the mean titer, we need the titers to be concordant to each other, meaning that they are within 0.1 centimeters cubed of each other, and the only two tiles which are concordant are this one and this one, meaning we will not use this one in the calculation. So the mean titer will be 20.25 plus 20.30 over 2, which is 20.275. So effectively what we need to do is we need to find the mass of ethanoic acid within the original sample, and the way we're going to do that is by making an equation and using our titration values, our volumes and concentrations to find out the moles of ethanoic acid and then the mass of ethanoic acid, and then we can subtract that by the sample mass of 5.6 grams to find the mass of sodium ethanoate, and then we do some simple division to find the percentage by mass of sodium ethanoate in the original sample. So let's start by writing an equation out for the titration. We have sodium hydroxide reacting with ethanoic acid, and that will give us sodium ethanoate and water. Let's write our concentration, our moles, and our volume table. So our concentration of sodium hydroxide is 0.35. Our volume is our mean titer, which is 0.020275. And that is in decimeters cubed, so we just divide this by 1000. And therefore our moles is going to be 0.35 times by 0.020275, which is 7.1 times 10 to the minus 3 moles of sodium hydroxide. And we don't need to write it in the table. As you can see, it is a 1-to-1 ratio between sodium hydroxide and ethanoic acid. Therefore, we also have 7.1 times 10 to the minus 3 moles of ethanoic acid within the 25 centimeter cubed solution. So we're told that they have a 200 centimeter cube solution and they make 25 centimeter cube samples out of them. So now the question is, how many of these samples fit into the original solution? So you know that 200 divided by 25 is 8. Therefore, 8 samples fit in to the original. So we're going to have to do our moles times by 8. Times by 8, and that equals 0.05677 moles of ethanoic acid within the original sample. Now we want to find the mass of the ethanoic acid, and we know mass equals moles times by mR, We derive that from the equation moles equals mass over mR. We just rearrange it. Therefore, our mass is going to be 60, which is the mR of ethanoic acid, multiplied by 0.05677, which is 3.4062 grams. That is already quite a few marks that we've earned, and that is the mass of ethanoic acid within the original sample. So I'm going to move over to this side to give me a bit more space. So we know we have 5.60 grams of the sample, that is the mass of the entire sample, minus our mass of ethanoic acid, which is 3.4062, and that equals 2.194 grams roughly. And therefore this is our mass of sodium ethanoate. So that is this mass. So we found our mass of sodium ethanoate. The question is asking us to calculate the percentage by mass of sodium ethanoate in the original sample. The way we're going to do that is we're going to do the mass of sodium ethanoate divided by the mass of the original sample times by 100 to find the percentage, and that is going to be 39.1% roughly. So that is all of the working. I've zoomed out a bit so you can have a better look if you need to. And you write the answer over here, 39.1%. Here is the mark scheme. So they find the mean titer. They allow a rounding of our mean titer to 20.28. I kept it there. I kept it as it was. They find the moles of sodium hydroxide. They say amount, but they mean moles. And therefore, yeah, they conclude that is the same. That the moles of ethanoic acid is the same. It has a 1-to-1 ratio. And then they're trying to find the moles of ethanoic acid within the 200 centimeter cube solution, and they just multiply it by 8 because we found the moles of ethanoic acid within a 25 centimeter cube solution. There are 8 lots of 25 in 200, so we just do 8 times the moles there and we get 0.05677, and then we do mass equals moles times mR and we get the mass of ethanoic acid within the original sample. Now we have the mass of ethanoic acid within the original sample. We subtract the total mass of the sample by the mass of the ethanoic acid, and we get the mass of the sodium ethanoate, which is the contaminated bit of it. And then we just do the division to find the percentage by mass of sodium ethanoate. Thanks for watching the video. I hope you found it useful. If you have any questions, please let me know.